Assalamualaikum warahmatullahi wabarakatuh. Di sini saya akan membahas salah satu unsur transisi, yaitu mengenai pembuatan besi. Besi merupakan material alami yang terbuat dari unsur ferrum. Bahannya terbuat dari biji besi yang ditambang dari alam, lalu diolah sedemikian rupa seperti besi kasar untuk besi cor. Pada proses pembuatan besi yang paling awal, biji yang telah dicuci dan dihancurkan dipanaskan dengan arang dalam sebuah tungku tradisional. Biasanya berupa lubang sederhana di tanah. Proses pembuatan besi dapat dilakukan dengan dua cara, yaitu 1. Blast furnace, dan yang kedua electric arc furnace. Teknologi awal pengolahan besi. Bukti kegiatan penambangan awal terlihat di endapan daerah Suriah dan Kapadokia. Eksploitasi dalam skala besar pertama terjadi di Germania di Turki Tenggara, di sebelah utara kota kuno Duluk, sering dianggap sebagai cradle atau iron making. Iron making, pengolahan besi. Pada proses pembuatan besi yang paling awal, biji yang telah dicuci dan dihancurkan dipanaskan dengan arang dalam sebuah tungku tradisional, biasanya berupa lubang sederhana di tanah. Suhu tercapai tidak mencukupi untuk mencapai leleh dan oksidasi biji dikurangi dengan karbon dalam keadaan padat, mengarah ke gumpalan yang disebut bloom. Ampas biji disingkirkan dan belum berulang kali dipanaskan dan dipalu untuk mengusir sisa ampas dan membentuk massa yang lebih padat. Biji yang diperoleh dengan cara ini sepenuhnya murni, dengan kandungan karbon rendah, oleh karena itu mudah dibentuk dan relatif lunak. Berikut ini adalah proses pembuatan. Proses pengolahan besi. Produksi material baja untuk struktur, mulai dari biji besi sampai menjadi baja profil atau baja pelat dirangkum secara sederhana sebagai berikut. Yang pertama, ada beberapa komponen dasar yang perlu diperhatikan. Komponen dasar tersebut diantaranya adalah iron ore biji besi, limestone tanah kapur, coke dibuat dari coal khusus untuk pembuatan steel, dimasukkan ke dalam blast furnace. Coke merupakan bahan bakar untuk furnace, dibuat dari coal dengan proses tertentu. Cairan besi yang panas di dalam furnace terpisah menjadi dua bagian. Bagian atas adalah slag dan bagian bawah adalah besi yang hendak dipakai. Besi yang dihasilkan ini kemudian dicetak menjadi pig iron. Kadar karbon dalam pig iron bisa mencapai 2%. Kemudian yang kedua yaitu pig iron dimasukkan ke dalam primary steel making furnace. Bisa berupa oxygen furnace, electric arc furnace, atau open hearth furnace. Pada proses ini, berbagai bahan kimia ditambahkan ke dalam furnace untuk mendapatkan material properties yang diinginkan. Seringkali, scrap juga dimasukkan ke dalam furnace ini. Di dalam proses dengan oksigen, karbon di dalam molten iron akan bereaksi dengan oksigen menghasilkan gas karbon monoksida. Gas ini harus keluar, kalau tidak bisa membentuk riming saat menjadi dingin. Untuk menghindarinya bisa menggunakan seperti silikon dan aluminium. Baja yang dihasilkan adalah cold steel atau semi cold steel.
Steel's applications are limitless, and its effects are everywhere. But how do we get from this to this? It all begins here, at a mine like this one in northern Minnesota, where precisely timed explosions are used to free a rock called taconite from the earth. The taconite is then processed into iron ore pellets. These simple-looking pellets become the base material for one of the world's most versatile and important products, steel. Each day, a mine like this can process 125,000 metric tons of iron ore. From the mine, via freighter or rail, the iron ore arrives at a steel mill. Integrated mills may cover several square miles. At the mill, the ore is offloaded from the freighter. Massive machines known as stacker reclaimers are used to move the ore into huge storage piles. The mill will draw from these stores to produce steel year-round, 24 hours a day. Another essential input for steel making is coal, but for coal to be used, it must first go through a process known as coking. To turn coal into coke, it is baked for 18 hours in a row of furnaces. This renders the coal much more efficient for the steel making process. Once the coke has been baked, it is pushed into a car and moved to a quenching station, where it's doused with water to cool it down, creating a tremendous amount of harmless steam. The cooled coke is dumped onto a conveyor system that brings it to storage. The iron ore pellets, coke, and also limestone all end up here in the blast furnace. This is where the raw materials first become hot metal. Modern blast furnaces are massive and highly automated. A blast furnace may measure 317 feet high, reach temperatures of 4,000 degrees Fahrenheit, and produce 13,000 tons of liquid iron a day. Iron ore pellets, coke, and limestone are transported to the top of the blast furnace and are dumped in. Technicians in a control pulpit carefully control the amount of each material entering the furnace. Superheated air is pumped in near the bottom of the blast furnace. The heat causes chemical reactions that draw the iron from the ore. Fuel and carbon are provided by the coke, and limestone draws off impurities. Gravity draws the liquid iron, referred to as hot metal or pig iron, to the bottom of the furnace. Impurities rise to the top and form a substance known as slag. When enough hot metal has collected at the bottom, the blast furnace is tapped. A robotic arm drills out a clay plug in one of up to 4 tap holes in the furnace. This allows hot metal to flow into a trench that leads to rail cars known as bottle cars. Slag flows to another area where it is cooled and collected. Slag used to be a cumbersome byproduct of steelmaking. Now it provides a whole new market, as slag is sold for applications like paving materials and concrete. The molten iron that comes from the blast furnace is not yet steel. Its carbon content is too high, so it is transferred in the bottle cars to the steel-making facility. Here, the hot metal is poured into gigantic ladles that hold up to 305 short tons. Sulfur is inserted for a chemical reaction to draw off more slag, and the ladle is positioned for a robot to scrape off the slag. Once this is done, the ladle is ready to be transferred to the basic oxygen furnace to become steel. Before adding the hot metal, the basic oxygen furnace is charged with a load of scrap metal. An overhead crane then picks up the ladle of iron and brings it to the mouth of the furnace, where it is poured in over the scrap. The furnace moves to its upright position, and an oxygen lance descends. Pure oxygen is blown into the mixture to cause a volatile reaction that reduces the carbon content of the hot metal, transforming it into molten steel. Alloys may also be added to customize the structure of the steel to a customer's specifications. Steel is the most recycled product in the world. Along with being used to charge the basic oxygen furnace, scrap is melted directly into new steel in what is known as an electric arc furnace. Loads of scrap are dumped into the top of the furnace and heated up to 3,050 degrees Fahrenheit. Impurities burn off and new steel emerges. Whether produced from new ore or recycled from scrap, the molten steel's next stop is casting. There the steel is drawn from the ladles and formed into a slab or billet. The shape is determined by what the end product will be. Slabs may become a coil of thin steel. Billets may eventually end up as rods or cable. Modern casting is continuous, so the steel is cast in an ongoing flow onto the line. At the desired length, gas torches make a cut to produce an individual segment. After cutting, the steel is collected and stored until it's ready for primary forming. At primary forming, the steel begins to take on the shape the customers have ordered. In the case of flat products like these rolls of steel, slabs go to a hot rolling mill. The slab is first reheated in a furnace to make it pliable for shaping. Then it goes through the descaler to knock off any impurities from the surface. After that is done, the red-hot slab runs through a series of rollers to flatten the steel. Each roller brings the steel closer to its desired thickness. It may go from a slab that was 31 feet long to a roll of steel that is 3,191 feet long in 3 minutes. The continued lengthening means that while the slab enters the line at about 2 miles per hour, by the time it reaches the end of the rollers, it is moving at 36 miles per hour. The ribbon of steel is then cooled with water and rolled onto huge coils. Long products like bars or cable are made from a billet that is first heated in a furnace. At 1800 degrees Fahrenheit, the steel becomes pliable and is run through a series of shaping points on the line. The process can be adjusted to meet the desired end product thickness. When the process is complete, a 40-foot 7-inch square billet may end up as a 1,000-foot half-inch steel coil or series of bars. After primary forming, the steel is further treated to meet end product requirements. Flat products go through a cold rolling mill. Here, the raw coil is placed on the line. Coils are welded together end to end to produce a continuous ribbon of steel that runs through the whole process. First, the steel runs through a pickling process that uses hydrochloric acid to eliminate any exterior corrosion or blemishes. The steel is then run through a series of rollers that reduce the steel to the desired thickness. Steel at this stage may enter the mill at 1/10 of an inch thick and leave as narrow as 2/100ths of an inch thick. At this point, the steel is too brittle for most applications, so it goes through an annealing process. Modern continuous annealing takes place in a series of furnaces several stories high. As it runs through the furnaces, the steel is heated up and then quickly cooled to lock its molecular structure into one that allows for the flexibility most customers require. Many customers also request steel that has been coated. To do this, the coil runs through a zinc bath. The steel is run through liquid zinc in a bath that is about 800 degrees in temperature. To keep the liquid clean, a robot is used to continuously skim the surface of the zinc. After the bath, the steel is formed again into a coil. When the coil is finished, it may be wrapped and then moved into storage until it is shipped to the customer to take on its new form as your car, dishwasher, artwork, or any number of things you use every day. Throughout the steelmaking process, products are monitored with strict quality control methods. Samples are taken, and quality is monitored by experienced technicians and engineers. The steel industry has always been a force in driving society forward. To do this, the industry relies heavily on research and development to find innovative ways to meet evolving customer demands and offer new product applications. Researchers are also looking to improve the steelmaking process itself. One key goal is to reduce the environmental impact of steel manufacturing. Water and air treatment facilities located in the mill are continually improved, and nearly 50% of today's steel output comes from recycled scrap. The steel industry has a proud past and a bright future, and is forging ahead to a tomorrow that is both economically and environmentally sustainable, so that steel continues to provide the foundation for so many products and the inspiration behind so many possibilities.